So I'm like, all right, whatever you guys say. Like, as long as I'm not getting the wrong stuff, I'm fine.
All right. So yeah, here we go. You mentioned something about the check. Let me take a look at that because I'm not sure what you're referring to. Oh, the check. Hmm. All right. Well, here we go. So you've got the vertex down. The first thing you would identify is the vertex. Okay. So vertex is 1, 0. You got it. And then the x-intercepts would also be useful, but this one doesn't seem to have any. They're also giving you some other points here,
Oh,
which is useful. Whenever they give you the vertex, though, you you want to start with the vertex form of the equation. So let's see here, it would be something like y equals ax minus h squared plus k. All right, so uh, that puts us at a x minus 1 squared plus 0, something like
oh,
that. And then we do need to find the value of a. You can do it the way you're doing it here. Um, you can also substitute these values into the equation. You know what I mean by that, or is that really unclear?
um,
Like I like this
could you
point
just
over.
repeat it like pretty similar to what you said real quick?
Yeah, this graph has got so much going on. So we're going to use this x and this y, and we're going to put them into the equation.
Oh,
So we have minus 1 equals a 0.75 minus 1 squared, like that.
a, oh, so wait, is that okay? Wait. So H and K is the I
Vertex.
forgot the name. The whatever to that graph. What would you call that point?
The max vertex. The vertex is either
Max vertex.
the max or the min. The vertex is either the max or the min.
Okay, max or min. And then to get X and Y,
I'm just grabbing another ordered pair.
uh, and it could be any ordered pair.
Yes. Although maybe there's ones that are better than another, I guess.
Oh, okay. Um, so then I put those in, minus 1 equals a 0.75 minus 1 squared, plus 0 technically, I guess, with that, but it doesn't really matter since
Yes.
you have it above. And then, so then, okay, I feel like my teacher hasn't shown that for some reason.
Well, I'm not sure how else to do this because I'm not sure how else you're supposed to know how to use this information here.
Yeah, is this for the check? Then if it's for check, I feel like that might be put into.
The check is like, does the equation also give you the same transformation as the original?
Oh, okay. I mean, I this obviously you know what you're talking about, so I think I'll just learn how to do it like this.
Well, this is a little weird. Like this check thing is not kind of standard,
Yeah. Let me
but
see
that's
how.
okay. That's
Mm, yeah, I don't have any notes that would explain it, unfortunately.
okay. Let's just keep going here. You're doing really well in this class, so even if this isn't quite what you expect, at least we'll
Yeah.
uh, we'll so this is negative 1/4 squared is 1/16. How do you solve for a now with this 1/16?
Um, a 1/16. You I guess would you just multiply it into that, or would you uh
So another way to write this is a over 16, because a times 1 is 1, or 1a,
Oh,
and then there's a 1 on the bottom that goes with the 16.
yeah.
Um,
So yeah, I guess -1 equals a over 16. Um, and then would I multiply it to be -16 equals a?
you multiply both sides by 16. That's right. So it is a equals -16. And then you use that back in this equation up here. So it's y equals -16 x minus 1 squared.
Y equals -16 x minus 1 squared. And then what exactly does that answer show?
This is the equation of the quadratic.
Oh,
And we did this last year, believe it or not. You know how to do the transformations of a quadratic when it's in this form,
oh.
believe it or not. So there are three transformations here. The first one is this x minus 1. Do you remember whether that moves it right or left? And if you're not sure, go back and look at the graph here.
It'll move it right to the one.
I'll move it right.
I
Yeah,
mean, it'll move it right one.
right one.
Yeah, yeah.
Okay, now the next one, and the order doesn't matter. It's either the negative or the 16. Doesn't matter. Do you remember that from previous class?
Um, then the -16 you said?
Yeah.
It would, so it does two things. So it will reflect it over the x-axis,
X-axis.
and it'll also stretch it by 16.
All right, good. Very good. All right. So now the question is, and so this is what I believe your instructor was looking for, which is the check here.
Uh-huh.
So we've got the equation, we've got the transformations. The check is like, does the graph reflect these transformations? Like, what does the parent function look like? I think we were doing those last time. The parent function looks like this, and the graph you have looks like this. So is it move right one? Like do you see,
Yes.
you can see it on the graph? Yeah, it is. Check. I mean, I don't know how you do it. Does it reflect over the x-axis?
Yes.
Yes. Vertical stretch of 16. So that's where, if you zoom in on your picture, let me actually zoom in on this and snip it. You kind of are showing it here with this 1/4 business that you've got written down.
Uh,
So this 1/4 right here, this 1/4 width is when you square it, becomes the 1 over 16, which is the reciprocal of 16. In your equation, we had 16. That comes from this 1/4 right here, because you end up squaring it and taking the reciprocal to get the reflection.
1/4 equals 1/16. Yeah, all right, I definitely see that. Um, 1/4, 1/16. All right, so I guess some of these problems almost look like, I don't know, the Terminator went through them or something, just the way they're all cluttered.
Yeah, it's like they were graphed from I don't know, like a early 90s grid. It's really,
Yeah.
there's a lot better things available.
Yeah, I just wonder where the teachers stole this from.
Yes, it's a great question. The math teachers never have to cite their sources, do they?
Oh, really?
Just think about that. In your English class, they really Where'd you get that from? And history as well.
Oh my gosh. Yeah, jeez, it's kind of funny actually. Yeah, I guess you can't really MLA format a math problem. All right, that would be a that's where it's x fx equals x times 3, correct?
X cubed, but it's got a standard form. It's got a x minus h cubed plus k, and it's also got an a. So they actually all have not really a vertex, but it's like a central point, a starting point. Yours appears to have one right there at 2 comma negative 1.
2 comma negative 1. So that's like my 0 0 equivalent.
Yeah. So from here you can substitute that value into the equation. So that's a x minus 2 square cubed minus 1. And then to find a, you have to use one of these other points that they're giving you that, boy, we're really hard to see, but I guess maybe this 4 minus 1/2. Is that what you see there?
Um, yes, minus 1/2.
All right. So we're going to use that to solve for a. So you always use kind of that baseline point to get you the vertex h and k, or that center point. Then use x and y to find the a value.
Mm-hmm. So, okay, so a x minus h cubed plus k. We see it moves down 1, and the numbers are moving to the right by 2. And then we took a random point, which was 4 and negative 1/2. And then the 4 stays the same. The negative 1/2 stays the same. Um,
So you first want to add 1 to both sides. Don't overthink it here. I mean, it's just
all
like
right.
other stuff you've been doing. Order of operations 4 minus 2. You got to do that first. That's 2 cubed.
2 cubed, 1/2 equals a squared cubed. And then that would be a 1/2 equals a parentheses 8.
Right, or 8a, and then you divide both sides by 8.
And then that would be
And if you don't like
uh,
that, here's another way to do it. 1 over 8, 1 over 8.
116. Okay, yeah, a would be whatever. I like that way a little bit more. A equals 116. So then would I insert that back in the original?
Yes, right back in here. So you have
Then minus 1/2.
no, not the line with the numbers. It's the one with just y, a, and x. It's right here.
Oh, my bad. Um, minus 1/2 equals 1 over 16.
Cubed,
X minus
cubed.
2 squared minus 1. Um, so then that is showing that the graph got divided by 1/16.
So it's a think of it as a vertical stretch or compress.
Uh-huh.
So it's a compress because it's less than 1.
So then I don't think I know what that means, to be honest.
Okay, so let's do the transformations here. Start from the inside here. That's right 2. Okay. Now the minus 1 here is down 1. Those are the ones that are most common.
Uh-huh. right 2, down 1. Right 2, down 1, and then shrunk by
Yes.
1/16.
Yeah, shrink or vertical shrink, 1/16.
And does that mean I'm dividing the numbers by 16 or then
The y values you're dividing by 16.
Okay, so then if it's like 2 and 8, it would become a half.
Yes.
And then that's what one of the points are on the graph, I'm pretty sure, correct?
Yeah, that's kind of what you're thinking of, is like the original xy to the transformed xy. So one of them is 2, 8. So the x value, right, 2 is 4. The 8 you cut in half or divide by 16. That makes it one half, and then you subtract 1 to get -1/2, which is exactly that point you said. Really good.
Okay, I think I connected the dots.
You did. Very good. Now the check, I don't really know. This is where maybe you got to talk to your teacher, find out what they're asking for here. I have no idea sometimes what they're wanting.
Yeah, I'm gonna have to ask her about it.
But any questions on what we've done? Because the C and D are kind of the same. We're going to do some more of them, but they're just doing more transformation business.
I don't really think so. I mean, it's all kind of the same as what I was doing in the past. Correct. I mean,
Yeah.
there's not too much variety, I'd say.
All right. So let's keep going here. So this one is a square root function. You've got that written down here. The square root function also has this kind of vertexy form, square root x minus h plus k. But this time that vertex point comes from where it starts.
Yeah, that's like the 0, 0 point.
Mm-hmm. So in this case, it's -1, -5. So you're gonna use those values in your equation. Y equals a square root x plus 1 minus 5 for k.
X plus 1 minus 5 for k. And then I'm just looking at it.
You got to use one of the other points to.
I'll do let's see, -2 and -4.5 seems a little bit easier than the other, I think.
Okay, so we got -4.5 equals. And there is another transformation here. So this is not quite right. There's a negative in front of
The
the X.
X, because
Yeah.
it's flipping over
Yeah.
horizontal reflection.
Yes. Yes. So this is, I've made a tiny error here, but nevertheless, we can get it. It's -2 plus 1 minus 5. So I would start here solving this by adding 5 to both sides of the equation.
So then that would be 0.5 equals a square root minus parentheses -1. So I just say square root +1.
Yes.
And then would I just write that with a square root after the a?
You can, I mean, or you can simplify. I mean, it is just 1. So a is 0.5. So that's going to go back in this part
To
here.
that. So then y equals 0.5 parentheses minus x plus 1 minus 5.
Yeah.
And that's Um, 0.5 minus x plus 1 minus 5. And then that is showing that the graph was shrunk by 0.5, reflected horizontally, moved to the left by 1 unit, and moved down 5 units.
Yeah, you got to do it in the right order, of course, but is that really -5? Yeah, it was. Okay. And then reflect over the y-axis this time, and then vertical compress 0.5.
Mm-hmm. Um, and why is it called a compress in this scenario, not a like stretch or shrink?
Oh, sorry. You guys use shrink.
Oh, okay, my bad.
Sorry.
I
It's
didn't know if it was like different in this or not.
well, it's like this. You got to use the language the teacher wants, and
Oh,
I don't know what they want,
yeah, no, it's all
but
good.
that's where you figure that out and use the word they want.
What so is it common for other terms to be used rather than stretch or shrink?
I always think of it as like your waist size shrinking. If
Oh.
you probably don't have that problem being a young, fit, young man here, but when you get older, you might struggle with that. So you might start thinking about shrinking your waist size.
Yeah.
I don't know, compressing your pants. I don't know,
Oh
just
man.
something to
That's a
think
good
about.
way to remember it.
um, the checks here again, the checks are, uh, they're okay here. So I don't know. I think it's good. D, we can move to D here. Do you want to try this one maybe more on your own since it's kind of similar to C? There is no negative on the inside. I'll point that out, but do you want to maybe try this one?
Uh,
Writing the equation.
yeah.
I'll
Okay,
help.
so
I'll help out here. It's x minus h under the root plus k.
do I have to with the square root or anything, or not square root, squared in
It's
this
just
problem?
there is no square. It's just the square root.
Okay.
What is your? Maybe I didn't understand your question,
I,
but
I
just
think I think that actually answers it because it doesn't use parentheses.
yes.
All right, let's see. So that'd be y and x equals. Minus so then -2 plus 1. Okay, so I have a question with this one. So currently I
Yep.
have 3 equals a square root 2.5.
Mm,
Um,
that doesn't. I mean, they wouldn't give you. Well, they did give you that. So yeah, and we can do the square root of. Well, it's 2.5 minus 2.
so 2.5 minus 2. How did I mess that up? Okay, yeah, so that's I have
This doesn't look
okay, so
right.
I have a question. So I wrote out 4 equals a square root 2.5 minus 2 plus 1, and then I subtracted the 1 on both sides to make it have. Oh, wait a second. I didn't write the minus 2 once again. I just wrote 3 equals a square root 2.5. So I need to write. So would a more proper answer be something like 3 equals a square root 0.5?
We're gonna have to make a little adjustment to this. The a appears to actually be inside here,
Oh,
which I don't know how you would know, but we should restart because this is not a nice number, so it doesn't work out there.
oh,
So forgive me here. Let me do this differently. So it's not even this. Apologize. It's y equals square root, and this is, we'll call it b this time. There is an a, but let's call it b, x minus h plus k. So it's like you said, though, it's the square root of x minus 2 plus 1, like that. And then we're going to use that other point now, and you'll see that it works out a little nicer. So 4 equals square root b 2.5 minus 2 plus 1.
4 equals square root b 2.5 minus 2 plus 1 minus 1. So then
Yeah, so this is
3 equals square root b parentheses 0.5.
Okay, so you're going to undo the square root first.
So is that just multiplying it by 2?
Yeah, just squaring both sides. So power of 2, power of 2.
Power of 2. So then that would be 9 equals b parentheses 0.5.
Yep. And then you can multiply both sides by 2 to clear the 0.5.
Yeah, so that would be 18 equals b.
Yes.
And then I would go back
to this line right here with the b and the x and the y.
and then that would be y equals 18 parentheses x minus 2 plus 1.
Yes.
So this one's done differently than
A little
the
bit,
other.
yeah. There's 3 transformations. The first one is right 2, up 1. And then this 18, because it's inside, it's a horizontal. And then because it's flipped. So like normally you think of 18 as being a stretch, but because it's inside, it's a compress or shrink 18. So everything inside or underneath is always opposite of what you probably think it would be.
So inside the whatever, it's just always opposite. And then
Yes.
okay. All right, yeah. I get that part. So on a problem like this, then so my question is there's the F and the A, right? No, B and X. What are the 2 letters we're using with?
Well, so the reality is that there is more than one letter. There's a square root b x minus h plus k. And it applies to actually everything. So there's, like, if you want to do a quadratic, there's a b x minus h squared plus k. And same thing with a cubic. There's actually more coefficients than they've been telling you over the years.
Okay, they lied. All right,
Yes, yes, they lied.
so we have those, and then bx minus h squared plus k a bx minus h. So the square root doesn't have the squared. All right, I guess it might just be worth moving on to another
Yeah,
problem.
yeah.
To look at
What do you want us to do next?
Let's see. I don't think we ever did a problem where maybe an absolute value.
Okay.
I'm not sure if that's not doesn't have any crazy rules to it. I'm pretty sure, right?
It is the similar form. It has a similar form. So, all right. Yeah. So like what I'm trying to say here is the absolute value one is like this: a absolute value b x minus h plus k, like this.
A b x minus h plus k.
Do we need to do e?
Yes.
Okay. E is what is e? Is it, of the ones we've done, which one is it most like?
I think it's like the absolute value one because it's like 1, 1, 2,
So
2.
absolute values are v's.
Oh,
What are
then
they? You
that's
should
a oh, what's it called with the 2? It's a
quadratic.
quadratic.
Yeah. So let's presume for a moment that it's a x minus h squared plus k. Let's just go with that. All right. Can you tell me the value of h and k in this one?
H is 1
Okay.
and K is 3.
All right. So we have a x minus 1 squared plus 3.
Um, and then we know that it's
So
1, 1, 2, 4.
you can use any of these points here.
We'll do 5 and 5. No, 3 and 3. 3 and 5.
Looks like 3 and 3.5. I might recommend the whole numbers, but that's it. That's your call.
Yeah, or I'll do is it a 3 and a 5 up there?
I think it's a 5 and a 5.
Okay, I'll do 5 and 5.
Okay, so go ahead and solve that for a first, please.
All right, so then okay, shoot, wait, I forgot how to. So I currently have 2 equals a parentheses 16.
Okay.
How would I reduce that again?
Subtract 5 minus 1 square.
Wait, subtract 5 minus 1 squared.
Right. 5 minus
Yeah,
1 is
so
4.
I'm currently at the yeah, that's what I'm currently at.
So
Where it
4.
says 2 equals a 16.
Okay, so 16a, probably a little better to write it, and then you divide both sides by 16.
16. So then would that just be 1/8 a?
Yes.
Or a equals 1/8, I mean.
Yes.
So you divided both sides by 16. By 16 equals
Yes.
16a divided by 16. 1/8 a over 8. Wait, no, sorry, a equals 1/8. Okay, so you have the 2, you have the 16a, and then I couldn't just make it become 8a.
No, you're solving for A, so you undo what's on the side with A.
Oh, okay. I'm solving for a, right, because it's a equals.
Yeah, you
So
did a
I'm
weird.
just, so if it's like 20 equals 5a, I divide all of it by 5
Right,
because I'm solving for a, which would then give me a equals 4.
right. One of the things you're not comfortable with, most students aren't either, is the fact that it's a fraction, the fact that it's 1/8,
Oh,
8 instead of being 8. You're like, why isn't it 8? Well,
yeah.
it's just not.
And why is it not working out? Okay, well, that okay, that makes more sense now, just solving. I wasn't looking at it as like solving for a. I was looking at it almost like try to get like a whole number almost, even though that doesn't really work.
Yeah, so this is going to go back into this line right here, and you're going to write out your final equation for that.
Um, so then that would be y equals 1/8 parentheses x minus 1 squared plus 3.
Yes.
But and then below we use the points 5 and 5 to fill up like the x and y thing as
No, no,
well.
no, no. That's it. The once you have the equation, you're good. You don't
Uh-huh.
you don't have to do anything extra.
Okay. Nothing extra. Um, okay, I think that one's kind of the easiest out of most.
Yeah, it was nice because they gave you some extra points, and they also yeah, you didn't have to do any other weird things here. So F is like one we did earlier. Can you think of that one? Which look back in your notes, maybe. Which one is that like?
Um, for F, you said?
Yes.
That looks like a shoot. I gotta remember. It's a where it's cubed,
Cubic,
cubic.
yeah. So your equation is a x minus h cubed plus k.
Ax minus h cubed plus k. All right, you can see off the bat the k would be -4.
Okay.
You can see that h is 0,
Okay.
and then you
Eh,
can use x and y. I'd go with I don't know, 6 and -12, even though
Okay.
they're bigger.
That's okay.
Actually, no, 3 and -5 would make more sense. I didn't see that they're both whole numbers.
A 3 minus 0 cubed minus 4. All right. Go ahead and solve that for A for us, please.
All right, and then that would be a equals -9. Therefore, leaving your final equation to be y equals -9 parentheses x minus 0
Okay.
cubed minus 4.
I think you made one of these classic mistakes here.
Oh
Just
no.
talked about add 4 to both sides. That's -1 equals A. 3 minus 0 cubed is 27.
3 minus 0,
Yes. You have to
27.
3 to the power of 3. 3 times 3 times 3.
Then that would be 927.
But more so, when you look at the side with A, you have a 27 and you're going to multiply, or you're multiplying by 27 to undo it, you divide by 27.
Uh, and then that would give you a equals -1/27.
Yes.
And then I guess that would make sense because you would be dividing your numbers by
Yes.
1/27th.
Yes. So there's your
All right, I
final.
guess you can throw some kind of logic into it by looking at it as well.
Right.
Okay. Well, that's just a simple little mistake.
Yep. Like putting it in reverse instead of first.
And then, so that would be the final answer in this scenario?
Yeah. Yeah. I mean, we've not really been writing down the transformations, but you can see it's reflected over the x-axis, vertical shrink by 21/27, down 4.
Uh-huh. Okay.
Is that unclear, or do you want us to kind of go through that more formally here?
Um, I think it makes sense because if you look at it, it's you're moving down 4, you're never moving to the right or left,
That's right.
and then it's reflecting. It has a shrink of 1/27th.
Okay. So we did, and we
Okay,
also,
so
you know,
that's
for the previous one, we didn't do the transformations. So we're gonna do
the last one I got for
okay.
sure.
All right, cool. Right. I don't know. We can talk about, we should do number 2. You were kind of asking about absolute value. We should talk about its transformations. All right. So this one has 1, 2, 3, 4 transformations. Can you give me any of them?
You can see that it is moving up 4 units. It is
That's right.
moving to the right by 1 unit. It is flipping vertically by or reflecting vertically. It is
So you got to say the axis, in my
reflecting
opinion.
over the x-axis, I meant.
Yeah.
It is getting the x values
So that's horizontal.
ranked by 2, divided
Shrink
by
by 2.
2.
Yep. You got it. Fantastic. All right. So you would make the graph, you would use the parent function for the absolute value. So your x, y, and your absolute value is the minus 2, minus 1, 0, 1, and 2, 2, 1, 0, 1, and 2. And then, like you said, the first 2 affect the x, and the other 2 affect the y. So you can actually do them all together. I vaguely remember me trying to convince you of that, and it didn't go well. But now maybe like you could see that you're going right 1, but then you are dividing them by 2. So this would become minus 1, but then you would cut it in half.
Oh,
This minus 1 goes right 1, so that's 0 divided by 2 is 0. 0 right 1 is 1 divided by 2, 1/2, and so on. As for the
okay.
y's, you can do the same thing. Reflect over the x-axis, you're negating it, and then you're going up 4. So -2, up 4 is 2, -1, up 4 is 3, 4, and you can see the symmetry there as well, if you wanted.
Oh,
Maybe maybe you don't want to do that. Maybe you'd rather do them one at a time. That's totally cool. It's totally up to
yeah.
you. All right.